Hello and welcome to Advent of Code 2016. Getting ready for problem number 22. Have Eclipse and Clojure here with my REPL. Let's take a look at the problem. Gain access to a storage cluster in a grid. Okay, got it. You can access node only on this thing, but you can perform some limited action. You can get the disk usage. The result of doing this is your puzzle input. Okay. You can instruct a node to move, not copy, all of its data to an adjacent node if it has enough space to receive. Nodes are named by their position, okay, X and Y. Before you begin, you need to understand the arrangement. Even though you can only move data between, going to need to rearrange a lot of data. Viable pairs of nodes. A viable pair is any nodes A, B, regardless of whether they are directly connected, such that node A is not empty, nodes A and B are not the same, and the data on node A would fit. Okay. Okay, pretty interesting. I see. Okay, so how do we want to do something like this? This is just the pairs, not directly connected, so it doesn't matter whether they're directly connected. All right. So before we get into parsing this, maybe what we should do is we should see maybe we want all combinations. Yeah, that looks pretty good. So we want something like the combinations of two nodes. How many viable pairs are they? Node A is not empty, which means its use is not 0. The data on node A, okay. Let's see. The pairs AB. So, all right. So something like this, and then filter. So I guess it's got to be the case that like not 0 the used of, like, instead of this, maybe like the first of this here, because we're having pairs. And then next we want to filter, it's got to be the case that the avail on the second of these is equal to, okay, that looks pretty good. Now, how are we going to define our nodes? Okay, def nodes to be, I think we can pretty much just map parse to our clipboard lines like this here. And then, or actually, let's do keep parse. And then our parse function, some s. All right. So is this a tab? What is this? Some number of spaces. So let's say that this needs to match some number of spaces followed by a thing, some other number of spaces followed by a thing, some other number of spaces followed by a thing, and then this is a 4-columnar kind of thing. In fact, why don't we just drop the 2 from clipboard lines right away, because we know that they're not going to match it. Then zip map. So these are name, size, used, avail, and use. Something like this. And then we want to add one more of these. All right, so 1, 2, 3, 4. And then to this, this thing, we'd like to update used with read string. Oh, interesting. Are these all T's in here? Yes, they are. Okay, all these are in terabytes. So then update used with read string of, let's see, they all have 2 characters on them. Maybe we can just do replace T with nothing like this, and then replaced avail All right, and then I think combinations is not right. I think permutations is, no, permutations. Let's see, combinations. Because we want both. So instead of combinations, we might just say something like for A in nodes, for B in nodes, when not equals A, B, when A is not 0, when it's, all right, read the problem statement. The data on node A it's used would fit, so that's at least as great as this. Then emit the pair AB, and then count these up. Okay. Copy this to my clipboard, and let's def these nodes. Here, here, a keep, right, like this, and we don't need that. Okay, and then nodes. What do we got? Null pointer exception. Great. All right, so we have used and avail. Why would we be getting a null pointer exception? 1, 2, 3, 4, 5, and there's 1, 2, 3, 4, 5 in here. I guess let's make sure that we're dealing with spaces here. We are. Okay. All right, let's see. Parse the nth of clipboard lines 2, like this. Pointer. Let's see. Okay, take this thing. That should be fine. Then it's got to be in here somewhere. Replace. Not seeing it yet. Let's try changing parse to this. Then does this work? No. What is the issue here? Oh. Do I see what it is? Yeah, because we're doing any number of spaces, we need to do at least one space. Yeah. Okay. Still null pointer exception. All right, at least one space followed by. Okay, let's change this character class to not a space here. Okay, then what? Size. Okay, that looks a lot better. Still null pointer exception. Okay, what's the deal? Used 24T. No, hang on. This is. Right. Okay, gotta go like that. Got it. Awesome. Def our nodes. Redefine our nodes like that. Then unable to resolve symbol. Okay. So it's got to be the case that the avail of B is at least as big as. Okay. 985. Right answer, rank 41. Return to the day. All right. Now that you have a better understanding, it's time to get to work. The goal, gain access to the data. So begins with node y equals, then highest x, the node in the top right corner. Okay. In this example, you have a storage grid, wide and tall. You can access directly. It's almost full. The node containing the data you want to access, which is this one. Oh, hang on. I see. Okay. All right. So you start at 0, 0, and then you have to get to node of highest x. Okay. Okay. It contains 6 terabytes of data, enough to fit on your node. If only you could make enough space to make it. Okay. Unfortunately, or fortunately, here we go. The node, this node here looks like it has enough free space to able you to move. In fact, it looks like all the nodes have enough space, which is okay, except this, which, okay. So initially, the grid's capacities and connections look like this. The node you can access directly is here. Okay. And that's where we want to get. This example, most of the nodes are interchangeable. Okay, but small enough. Okay. Empty node, very large, very full, and the goal. Then it looks like this. The goal is to move the data in the top right G to the node in parentheses. To do this, we can issue some commands. Okay, move data from U to U. Okay. However, we have no deletion commands, so we have to move some more data around. So next we move the data here, move the data there to there, okay, all right. Okay, this is starting to, what's the fewest number of steps required to move your goal data to this node? All right, so our node is Y0 with the highest X, which looks like 31. Okay, all right, so I think our moves are pretty well defined. Let's pull out our breadth first search. This, yeah, that looks fine. Extra color in it here. Actually, let's pick a different breadth first search. This older one. Okay. Now, all right. So interesting. Interesting. I'm not sure breadth first search is gonna help us. I think we might need. We might need a. Yeah, we might want to put a heuristic in here at the very least. Yeah. So. All right. So let's see. How do we want to model this? So our nodes right now are, they don't have positions associated with them. So I think we got to do that. So let's see. Okay, so we do need size. So let's put that in. All right, and then I don't think that we need use percentage because that just falls from everything else. But what we do need is, let's do something in here like parse coords to this thing. For a node, and then what do we want to do here? We want to do like a regex match on, so the regex match is changing now. Now it's dev grid node xy. Okay, pretty straightforward. Dev grid node x this, y this. So then let's do a zip map of x, y. Then to this thing, update x with string, update y with read string, and then merge node in here. Enable to resolve x, right? It should be. Oh, right. This needs to be the, what are we calling it, the name. Enable to resolve symbol s, right? The name of the node. That, update that. Index out of bounds. Okay, so that looks pretty good. Very good. Okay, great. So let's redefine our nodes here and then put this def once in there so that we don't keep redefining it. Take 3 nodes like this. Okay, so for a, okay, so then actually there's one more thing that I want to do to these nodes. I want to decorate it with a goal. So let's see. So we say something like X is 31 and Y is 0, then we want to associate in this goal true. Is that the right state that we want? No, actually it isn't, because we want to be able to do an efficient lookup of a goal. So our starting state is going to be one where we have nodes given by nodes like this, and goal given by 0, 30, or 31, 0, like that. Yeah, it would be kind of nicer if nodes was in a better structure for this. Yeah, that sounds pretty good. So this is, I'm gonna redefine our maps here. I'm gonna say for node in this, we want to emit the X of node, the Y of node here to node like this, and put this into a map. Okay, how big is this map? 992, which should be 32 times 30, 32 times 31. So def wants this. Okay, so now at least we have an associative data structure. We need that. And then we will redefine our starting state here. Okay. All right. Now what? Now we need to define our valid moves in a state. In a state. So I think, so actually we might be able to repurpose this code here. So basically, for A and B, so change this to, I guess, keys node goal like this. For A and B in nodes, A and B like this, vals. So, yep, and then we do want that. We don't want this, but then we basically want to say, we basically want to represent a change in moving data around. So what do we want to say? That's something like we want to have a new state where, okay, so we want to take, so let's say this is as state. And then we want to emit a new state where we update in so nodes. So this might actually be better as key A this, and then no longer over the vals. Something like that might be okay. Key and B. And okay, update in nodes key A. So we're moving data out. So its used is going to be take the value that's in it and subtract the zero it out, right? Because we're moving all the data. So assoc in with 0. That's my understanding. Then we're going to do update in nodes key B of avail by taking the value and subtracting the used of A. Okay. Then I think we need to say something like if goal is equal to the key of A, and we're going to do something special, otherwise it's just the state. Then in that case, what we need to do is we need to associate state goal with key B like this. All right, so this is updating the used of key A. And then I guess then we also would need to update in the avail of key A by adding the used of A. And then similarly, it seems we need to update the used of key B, adding this number to it. Okay, that defines, all right, and then a state final is final when what's that for now? When equals goal 0, 0, because that's where we're starting at. Okay. All right, so then we're basically saying BFS starting state. This. Do we have a definition for starting state? This won't be too big, right? Yeah, okay. All right, let's try this, I guess. 985. Huh. Yeah, seems pretty slow. Yeah, not sure if it's. I think. Yeah, I think the branching factor is just huge, right? Because because if there are 900. Yeah, no. This is, yeah. So we're not doing any sort of restricting based on things being next to each other. Okay. Yeah. So maybe we need to do something like let's do this, like adjacent nodes for a state, and then how would we do something? Actually, this won't be too hard. Yeah, I think this will actually be pretty easy. So we say basically for, let's see. So I think we say that for x in range 32, y in range 31, we want to emit, so let the source be get nodes x, y. Okay, that looks pretty good. Then for dir in 0, 1, or list containing list 0, 1, 0, neg 1, 1, 0, neg 1, 0. Let dest be get nodes. Nope. For dir in. Yep. Get nodes dir like this. In fact, nodes just acts as a function, so we can just do it this way. And then we say when dest, in case we go off the map, then we want to emit. The first thing is going to be So I think there's a find function. Yeah, so I think if you find given A1 like this, yeah, so this does return a key value. So we want to return where the first element is find for dir in nodes of, so this is actually map plus x, y, dir, like that. Oh, turn the music off. We want to find xy, that's the source, and then find map plus xy dir, that's the destination. This would be a vector. Like that. Okay, so what are the adjacent nodes in, I guess, the nodes of the starting state? Something like this. Wrong number of args passed to 4. Right. Yep. And I think we just want to count these. Wrong number of args passed to find. Right. So find nodes like that. Okay. All right. And then can we get the first one of these? And this is saying from 0, 0 to 0, 1. How about the nth 100? Is saying from 1, 2 to 2, 2. Okay. So far, so good. That looks pretty good. And then basically we need to say for, let's see, so key AA, key B in adjacent nodes of nodes. And then let's see, then we don't, so now we no longer need this check because they're never going to be the same, but we do need the check on bounds here. Okay, so let's see if this runs a little bit faster. It does in fact run a little bit faster. Okay, unfortunately, doesn't look like it's going to be fast enough. So I think we have to introduce a heuristic. So, all right, so our heuristic for state is going to be, so I think what we can do, so goal, okay, all right, so let's get the goal, jail, I keep spelling jail, goal of the state, and then what? We want to say like, so I think actually we can just like apply plus to it like that. And then what that will say, yeah, that this is actually an admissible like A star heuristic. So we're not going to use this like A star, although we might have to change that. But what I will do is I will sort by the heuristic, actually in minus of that heuristic, and then let's see, how many should we take? Like maybe 100 in here. See what this does for us. Yeah, I might actually have to do an A star. So let's see. So I think our heuristic is correct. I think it's what we want for A star because it's never gonna it will never underestimate the length that we have to go. So is there a way to make a nice map that's assorted by? Not sure. Also kind of hoping that we get oh, that might be promising. So yeah, we know that the minimum number of data transfers that it's going to take is 31, I guess, and it's probably going to take more than that. So in order for this to give the right answer, we would, I think, basically be only looking at the 100 most probable, the 100 closest. I wonder if what we could be doing also at the same time would be to report the like max of these. That might not be a bad idea. So like something like the apply min of yeah. We could pop something in here that goes just like report heuristic, or would that work? No, that wouldn't even really work. Yes, it's possible that it would be taking this long. Give it a little bit more time, and then I guess separately, what happens if I search for Clojure A star? Couple of examples here. I'm mostly just concerned with what the map data structure. Yeah. So we got here priority map by. I wonder if I have access to Clojure data priority map. Require Clojure data priority map. That's not found. I would need to Clojure priority map, or priority queue, I guess. Let's take a look. Okay, here's a definition. All right. Priority map, very similar, but whereas entries sorted by value. Okay. This all looks pretty good. Can I go into my Advent and start a new REPL here, just in case this ends up turning up a useful answer, although that's looking less and less likely. And all right, let's connect a REPL here. I think we can close this. All right, and all of this stuff should be fine to bring in. Yes, Java. Oh, right, I need to redefine my nodes. So this content's here. Okay, like that, and like that, and leave these out of it. So how many nodes do I have? 992. Very good. Okay, and then it's saying here that there's such a thing as priority queue by. So let's I'm not a big fan of this use here because I don't know what I'm bringing into my namespace, but so do we have priority queue by like this? No, did they define it? Well, priority map by. Okay. So let's see if we have it. So we do. So let's see. So let's read the documentation here. Priority map by. Use a custom comparator. Okay, so we want our state map to be a priority map And then I guess by this, hope. Yeah, I think that's what we want. And then the map starts out as state to 0, like this. Still looking by that other one. Okay, and then I think no longer do we want to maintain edges. Instead, what we're going to do is we're gonna, yeah, okay, I think I see where we're going with this. So we're gonna let this node here be, or, all right, so if I do have something like this, no, maybe not in this. Okay, let's try this and then able to find heuristic, but I defined it right here. For error, even count the key vowels. What is the definition? I see. So it doesn't want me to put these things in there. Okay, that looks pretty good. So basically, what happens if I ask for the first of this? Is it going to give me the key vowel? Or how about the F first? Okay. Okay, that looks pretty good. So, all right, so then what we're going to do, I think, is we're going to let the node and the distance be the first of state map. All right. And nexts are going to be the valid moves in node. Okay. Then I think recur on increment nn, like that. And then like merge with min, state map that we have so far, and then a map of, let's see, into a map of 4 next node. In the nexts, we're going to put in next node, and then increment an n like this. So we're never actually using this n here, so take this out. So just replace that. All right, so that's going to make a map of the new things. Let's see. Yep. I think this is all good. And then, so now we need a terminating condition. I think that we say if some, yeah, see, I'm not totally sure on this. If some final of the nexts, then and what? Let's so we can emit like this, that's how many steps it took to get there, and then rely on our heuristic to deliver the closest one first. I think so, because distance is never, the distance between those is always 1. All right, so let's just call this A star. Enables to resolve the element. So what's the end of file while reading? Did I change something? Must have changed something. Like up here, maybe. Nope. What is the issue? This thing here. Unable to resolve symbol N. Okay, that's more reasonable. All right, don't need to do this anymore. Okay. Then I do kind of want some optics here. What happens if I do this? I hope this doesn't slow the program down too much. And it's still looking at an N. Like this. All right, so let's try here. A star starting state. All right, that already, okay, yep, same bug as before. Okay, I don't know how to create a sequence from next. What's this all about? Let's see, right, like that. Wrong number of args past a heuristic. Okay, that's good, I guess. So it's passing 2 arguments into the heuristic. Let's read the documentation for priority map by comparator greater than. Oh, I get it. Yeah. So actually, so is there closure? Can I just make a comparator out of comparator based on pred? Comparator returns a negative. Okay, so I think, so let's see, let's read the documentation here. Okay, so in this case, greater numbers get popped off first. So I think that what we want to do is, given A and B, find the difference. Right, so in the case of greater than, if it returns true, like it does for AB, then that means that A gets popped off first. So in this situation, I guess we'll want to put, so when would A want to get popped off first? So like that. Okay, then what happens when I try to run it? Boolean can't be cast to a number. Minus. Just by heuristic like this. Okay, so looks like it's doing some things. It's 5, huh? Okay, so this seems to be implying that. Okay, so I think, yeah, so what's going on is I keep adding to my state map when I really should be replacing it. No, I think I need to dissociate. The thing is maybe if I just replace this with this with less than or equal to, then I'd get the behavior that I want. No, it's still getting stuck. And I think the reason is that I'm exploring states that I've already explored. So let's see. Okay, so I think I just want to take, like, I think I just take valid moves and I just remove anything that's in the statement. Still getting stuck at 75, huh? So I guess that what's happening is it's the next is just empty. So there's nowhere to proceed. So, okay. So I think then in that case, we need to go like for state in the state map. Node n this. Let the nexts be like this. When there is at least one nexts, then we want to emit those here. Something like this. And then the rest, I think, looks good. So we're going to need, oh, why is that still okay? It's unable to resolve symbol n. Yeah, so maybe like this. Okay. Gosh, just one. That can't be good. Take a glance at our reference here. Search. Priority map by, okay. And this is a recursive definition here. Draw map. Edges. Yeah, it's using like an open set here, which is it's using like a queue. It's popping things off. Because once we pop something off, we don't want to continue to explore it. So okay. Well, you know what we could do? We could. Let's see. Find valid moves like this. I think we need to. Like, need to like remove the node that we found here. Okay. So maybe like something like that, and then dissociate in here the node that we just explored. One. That's not good. So this is just cranking. Let's see. All right. let's start back at, okay, so this is a priority map by, okay, so it's a mapping from this, from state to the number of steps that it takes to get there. Okay, mapping it by the heuristic. Got it. So then I think we want to, all right, so I think I like something like this, because what we're going to do is we're just going to push these nodes into the queue. So go over everything in the state map. Yeah, okay, I think I like this. No, I don't, because it's gonna blow up. We need to like recur as soon as it finds a, so could we go like this, like map valid moves. Okay, so for node and in state map, do this. Okay, so we're no longer going to have to do that. Just look at the moves that are next up. Then what? So I think we do want to, so let's take a look at priority map here. Pop removes the first item from the collection, not unlike rest. And seek pop returns out okay. Right. Okay. I think I might have this here. So something like let first, or let like node n be peak state map. Okay. Then we're gonna recur on pop of the state map. We're going to also merge for, so we're going to want to put our nexts in here. So next nodes are going to be the valid moves from our current state here. Then I guess we would also want to filter by, well, okay, let's just leave this for now. Then for next node in the next nodes like this, we want to emit something like node increment n. I think that sets up our basic loop, and then we still would want this termination condition in here. And then what we don't have is pruning based on, so enables resolve small next. Let's try this. We need some optics. All right, null pointer. Why? Where? In adjacent nodes? Maybe that's because something like this. Okay. False. Okay, that's not it. So the issue seems to be in this adjacent nodes here. Okay. So nil is getting passed in. Nil can only get passed in here if, let's see, probably valid moves. Interesting. So what happens if I ask for the nodes of essence? Nil? Well, that doesn't look right at all. So this is, oh, it's a list containing a state? Okay, I think I can work with that. So, right. This needs to be into a map. This. Okay, A-star search. All right. 32, 32, 32, 32. Interesting. So, okay, so seems like it's making progress. Seems like the map is changing. Yeah. I wonder if the priority map doesn't support count in the way that we expect. Because how can the vals have this many values in them if there are only 32 things in there? Yeah, it's saying that it's explored all the way out to 1,000 moves here. At least that's how I interpret it. What is the first of M? What is the goal of the first of M? Nil? Oh, right. Yeah, what's the goal of the key of the first of nil? 31, 0. Well, that's not good. Maybe our heuristic is backwards. Maybe it needs to be like this. Oh, or maybe just like we had to do like that. So change this back to a less than. Long can't be cast to a map entry. Okay. All right, so I guess that's not the case then. So priority map by the heuristic. I think I see what the issue is. Yeah. Yeah, the issue is that this is comparing the values, and it needs to be comparing the keys. All right, let's see. Priority map key fun. guess what we have to do is we could change this to like a map from sort of like more like we need a priority set. Could we change this of just like a map from the state to the state like this? Is that so super ugly that it will never work? And then we would just like emit those final nodes here. That actually tell us how we got there? No, it wouldn't. But let's try running it and see what happens. Okay, don't need to do this anymore. Don't need to do that anymore. Yeah, would be nice. It would be nice to just have it return. But what we can also do in the meantime is get the first of M, right? Get the full of the first one. Okay. Then I guess try this instead. So I think A star is right. I think that my A star is just not implemented correctly. So I guess we could take a look at this is pathfinding. Is this the same thing? Yeah, it's the same link. Let's see. Implementation, the A star search and closure. Okay. All right. Where am I supposed to actually look for this thing? Interesting. Okay, a lot of code here. Okay, this looks good. Yeah, closed and open sets. Well, let's see how other people are doing here. All right. So we're no longer in the rush period, and but only. Oh, hang on. No, we are still in the rush period. Never mind. All right. So yeah, let's see if we can courageously fix this issue here. So, all right. Let's see. So we want to maintain a queue of the nodes that we want to look at next. Let's try not using any fancy data structures. Let's just say that we're going to start with state-like. And we're going to, so do normal maps support pop? Do they at least support first and rest? Yes. Okay. Oh, actually, okay. So I've got an idea. Okay, we're going to use a priority map by, except the priority map by is going to be based on this. And then this is going to be state to heuristic in state like this. And then this looks good because we're going to take the first one off. This looks good too. This condition here, what if I just say like that? Then we're going to say heuristic on this node. Let's try something like this. And heuristic has now got to be state, and then let's just put this in here so we know what we're working with. And then okay, put this up, put that up, that two. All right, and run this. All right. Okay, now it's saying the count of m is 5, but count on a priority queue might be funny. Let's see what the first, or let's see what the distinct vals of m are. 31. So it's saying it can't get anywhere that the heuristic just doesn't return 31. Huh. Huh. I wonder if this other thing also, well, actually here, let's get the class of m just to verify. So this is a persistent, this is a priority mount. So pop this off. That seems right. And then make a map of, yeah, even breadth first search was doing better than this. Valid moves, Yeah, why is this not? Why is the size of the map at least not going up? Okay. So in that case, here let's use a plain old closure map, which at least we have better understanding of, and then say this is going to be the first of sort by the negative. Nope, just the heuristic of the key. Like that. Or I guess no, because it'll already have that on there. So that node, and then yep, okay. And all right. Then I guess isos node that we put in. Now do we at least get the growing behavior here? No, we don't. Do we need to? Should we possibly maintain a closed set? You know, something like closed like this, then remove closed, and then recur on that. Okay, and then in this situation, so we can get stuck here. So let's say let this be 4 kV in here. Let this be this. Oh no, never mind. This shouldn't be necessary because we're popping like eventually. Yeah, eventually this is just going to be empty. So so it's something like if not seek state map fail, otherwise run this. Okay, so it does look like it's exploring. What are the distinct of the vowels of M? Only 31, it says. Is our, so are we updating the goal state properly? My guess is that we're not. So let's see. So if the goal is equal to key A, all right. Okay, so let's just take the first of the key of the first of M, this, and something like that. Okay, then try taking the valid moves and like map goal to it. So this looks like that what it's saying is all. So, okay, so it's saying that there aren't a whole lot of valid moves to make. That's pretty surprising. Maybe, yeah, maybe that's just if most of the, yeah, I guess if most of the nodes are full, I guess we would have to have at least some that were like at, less than 50% in order for it to be possible. Right. Aha, that's interesting. So it looks like there's only, there's only that many moves to make. There's only going to be, well, in that case, shouldn't there only be, right. So actually I should use 0 because, yeah, that's actually, so I should have done that. Greater than used on a 0. Just pause. Yeah, that actually seems like a pretty important. Yeah. Okay. All right. Let me try running this again. Okay, it's getting out there. Would be distinct vowels of M. So it's doing all of this work, and it isn't getting any closer. But at the very least, it does seem like it's moving. What if I ask what are the distinct keys of M, or let MM be M, and then the distinct keys of count this. All right, so we are finding distinct states here. It's disappointing that it doesn't seem like the goal. Let's see. Yeah, maybe. Maybe it's just like a sanity check. Yeah. That's actually pretty cool how we can modify the behavior while it's running without having to restart. And yeah, I mean, it looks like it's just exploring a bunch of nodes that really do not matter. I think that part of what this is that our heuristic is not strong enough. So maybe what we need to do is something like maybe like we also want to find the empty node and measure its distance to the goal. So I guess, yeah, what if I took let's try filter based on, it's got to be the case that the avail or the used in here is 0. Based on the nodes of the state. And it's actually not so it's actually the val. Here, then get the key out. Then something like apply the difference to the goal state, like this. Number of steps that it would take to get the first empty node to the goal state. I minus, so it should actually be map minus. Add that to this. Lazy sequence can't be cast to a number. What is the heuristic in the starting state? Same thing, heuristic can't be cast to a number. Okay, it found that. Can I get the key out? No. Okay, so then I see. So then probably like this. Yeah. Okay. So the first of the first. That here. Then so it's saying that you can't map minus to the goal of the starting state and 2820. Looks fine to me. Is it this part? This also looks fine. Oh, no, it doesn't. Seems to be this. I don't know how to create a sequence from longs. Map, y plus 2. Okay. Okay, so apply plus to this. Three. So what's the problem here? My guess is that this isn't being enclosed at the right place. Okay. All right. Let's try this then. So this ought to give us a heuristic that's at least a little bit more. Okay. Yeah, this seems to be saying that it can't get the 0 node any closer to the any closer to the goal. Yeah, this is almost like one of those puzzles with the empty with like the 16 tiles that you can slide, and like one of them's empty. So with the old heuristic, this only gave us one. Oh, I see. This is right. So it's exploring all kinds of nodes, but none of the nodes that we care about. And we are sorting by this value here. Do we need to like report the heuristic on the node? Something like this. It seems to be saying that most of the nodes that it's exploring don't have any move that improves our position. Which is just hard to believe. Well, at this point, we're competing for the last 4 points here. So I'm going to call it for the night. See if I can look up a proper A* search definition in Clojure and apply it. Might need to come up with a better heuristic here. Or might need to actually just render the problem and see if playing around with it gives me a better idea about how to approach it. Yeah, I will follow up with a solution video once I've gotten there, and at the very least, I'll see you tomorrow for day 23. All right, thanks for watching.